Hey man, you ever look in the flatter?
Okay, I wanted to make a comparison video, pretty much. Um, in this first video, and I will put a link to both the videos that I use in here. And then I want to also link another video. But this video was from sun departure, corpuscular rays, and anti-corpuscular rays. Um, but my main portion right here, or my main part for showing this cell phone footage, is not really to show the anti-corpuscular rays, which should be absolutely impossible on a ball Earth. But besides that, I wanted to kind of show you where my camera height was of my camera. And here in a minute, I took a screenshot right here. And my camera is approximately 8 to 10 feet. I believe it is actually more of about 10 feet because the tide was down below the seawall about 4 feet. Then you have my tripod sitting up 28 inches, and then it's sitting on the picnic table, which was approximately about 3.5 feet off the ground. Um, so again, my main thing was to show this um, sun comparison on a day where there's heavy mirroring in comparison to where there's hardly any mirroring or a very small sliver of mirroring. Now, if you notice the boat in the background fixing to come up to this halfway marker, and also notice where the horizon line appears to be. Now, that horizon is, or that marker that's out there, the little rack to the left of the middle of the screen, is approximately a mile and a half, mile and a quarter away. This channel goes out and it does a lot of curvy derby. So, if you're in a boat, it's going to appear to be further out because you're traveling, curved lines and not straight to it. But if I was to go out straight to it, it's approximately a mile and a half, mile and a quarter away. And again, you see the boat appear to be floating above the water. Now, at a 10-foot height, that horizon line should not be that close, but this is where the mirroring occurs, or when it happens. And what it is we get this dense air above the water line that actually obstructs our vision to see where the true horizon line actually is. Now, people say, oh, or science will say, oh, it's pulling things up from above the curve, beyond the curve. No, that boat should not, it wouldn't have been being pulled up above the curve. Um, in other words, basically, the light is being bent upwards. A lot of us look at it as, kind of like a downward refraction, but it's actually the light is bending up. And what is it bending up on? It's bending up on the evaporated water that's above the water. So in turn, um, this band of water, and you could call it an aqua band. That's what I look at. And the farther out it goes, the more evaporated water you're looking through. So in turn, what it does is it bends everything upward, blocks out the lower portion, and it blocks out everything beyond. So in turn, at a 10-foot height, I should be able to see much farther than 1.25 miles, 1.5 miles. But obviously, you can see that this is a false horizon line, and it is the weather conditions that are stopping me from seeing any further. Um, and this is the point that I try to make in a lot of my videos, is to pay attention to these bird racks, channel markers, islands, um, because that's where I am getting my information and learning a lot more about observations. And when you want to speak about science, what's the biggest portion of science? Observations, right? Because if you don't observe it, then how can you make any kind of assumptions or theories or anything on it? You have to be able to compare, especially in observations. Now, check this out. Watch this sun come up out of the sea and meet the other sun. What is there, two suns out there, one meeting the other? No, that's all what's being hidden. Everything's being hidden below the sun. So what happens is we get this appearance of the sun vanishing into its own reflection. But actually, it's being hidden by the atmosphere. Obvious when you do many of these observations, and it really does show you. And I should have at the transition. It was I sped up the video 2 times the speed so it wouldn't be as long, so I could get through this video and show um, my theory, or my outlook on why we're not able to see certain things. Now you have optical magnification too, which basically I've seen the sun look absolutely huge compared to other days where the sun looks much smaller. And that's not even with a camera, that's with my own naked eyes. So again, you look at where the sun vanishes at. Um, that's, we want to call that the vanishing point, but the sun's still there. We just can't see it through the atmosphere. And then this was one I did, Flat Earth in Search of the True Horizon. Camera height is approximately 2 feet, 28 inches, somewhere in there. And then we also still have some blockage here. But later on, after the sun departure, you will actually see, I've got like 6 parts to this video. So part 4, you start seeing more and more of the true horizon line, where the true horizon actually is. And there's Bayport Bird Rack is going to be out there that you'll be able to see. Um, Cutter's Rock is visible on this particular day. Actually, all the racks are visible. Cutter's Rock is 11.22 miles, and Bayport is 3.5 miles. Maybe a little more, maybe a little less, but not much. But you do see this aqua band going way higher than the bird rack. Now, with a other observations that I've made with the virtual horizon, um, I've determined that the rack is the horizon line is above the Bayport rack. And people say, well, how can it be above the Bayport rack? Because of perspective. Okay, when you're looking at an object farther away, it is smaller. But when you can see more of the horizon well beyond it and above it, it's telling you something. Now, part of that is, again, the aqua band, and it is bending light up. Because no matter what, on most of my observations, I've never had a day where there wasn't either major mirroring or a very slight amount of mirroring, and that mirroring would be way out in the distance and much farther beyond where I should be able to actually see. Now, here I'm showing you my, I had this B700 sitting on the seawall, which it's about 18 inches up. Um, Probably less because as the tide came in, the water rose, of course. Um, but my main thing was to just show this part right here, and then when this next transition comes up, it's going to be sped up 2 times the speed. Um, and my whole thing is to explain um, how much of this is getting obstructed. Miles, hundreds of miles, I believe, because there's no way that I should be able to, see the distance that I'm seeing, to the sun when we're looking out there. Now, I say that the Cutter's Rock is 11.22 miles out, and you will see it in this footage. Um, Now, it is being stretched, and that's why I say that there's some uh, optical effects that occur that stretches things out, and that's why the horizon appears to be higher than the Bayport bird rack. Okay, because farther out there, that light is being bent up, and the sun is reflecting its light off of that aqua band. That is not the true horizon much further out there. Um, it is a little bit below that, and I'd say almost where you can see the dark line in there is where that aqua band is. You almost see it. It looks like you're looking through a kind of like a tunnel. You see the slots in the water. Um, just look up at the bird rack to the right and just think about it being just above the top of that. And the rest of that is mirroring, a mirroring effect, and it's mirroring off the aqua band, evaporated water, the weather condition, whatever you want to call it. We've seen many people call it all kinds of different names, but that's my particular outlook is that water goes well above the Bayport bird rack and the Bayport entrance bird rack, because there's a Bayport north rack. We call it the north rack, but it is a Bayport north rack. I don't know why they call it the Bayport north rack, but all in all, I think all these channel markers out there is for navigation, for boaters like me that go offshore, can find our way back without having to guess on our locations. But another thing too is the compression of the sun, and how the sun changes its shape. It will go into more of a flat um, bottom half or oblate spheroid. But I've had them where they've gone almost completely flat at the bottom of them, and it is actually amazing how much is actually getting blocked off from your horizon. Now, could the horizon be going beyond this? Well, yeah, but it's beyond our angular resolution limits that we get. So, or let me put it to you this way: visibility limits coincide with your angular resolution limits. The better the visibility, the better your angular resolution. And that's something that you just do your own science on that. Once something gets to such a sharp angle, you cannot resolve it. It's going to blur out. We also see a lot of distortion sometimes, especially here in Florida. Because what do we have in Florida? A lot of high humidity, and with that high humidity, we get basically a lot of distortion. So when people say, "Oh, you're out of focus," no, I'm not out of focus. I'm in the best focus I can possibly get. Yeah, sometimes I am out of focus, but most of the time I'm within focus. Now, somebody would say, "See, you're proving that it's a globe. You're proving that it's going over the curve." No, 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 no. It's an optical illusion. How much is being blocked out is a lot. A lot's being blocked out. And where is the true sun? That's another thing. The light itself is very hard to focus on. And when they tell us that it's 93 million miles away, but yet I can focus on the sun and focus on a closer object at the same time, I have an issue with that because normally you cannot do that. It will not focus on an object 93 million miles away and something up close. Now, that's another thing when you're filming the sun. If you take it out of focus, you will get a much bigger appearing sun. So again, when I'm focused on something close to me and the sun's beyond it, is that sun really in focus? I mean, it might look like it's in focus, but it's not. And again, everything that going beyond. Now, right here is a perfect way to see where that. There's the true horizon, just above the bird rack. Now, at 2 feet, I should not even see that bird rack. I should not see the Bayport bird rack, not all of it anyhow. I mean, at 2 feet, that thing should actually be below the horizon, but yet it's not. And then you'll see this boat as it goes along too. Um, it's kind of like stretched upward a little bit. It's kind of like being towered. I guess they call it towering. I just call it being stretched up, or it can be compressed down. And I've seen it get compressed down quite a bit. Now, here comes Cutter's Rock, and Cutter's Rock is going to be stretched. Yes, stretched. And again, I should not see Cutter's Rock at all. Now, a camera cannot have an optical effect on an object that it cannot see. And when science says it's this magical force of refraction pulling things up, I say no, it's the magical force of the whole thing getting hidden by this aquaband or this evaporated water or the weather conditions is going to block you from seeing things. That's why you have different visibility limits, and that's why people need to pay attention to that. And how can you have an 11-mile visibility when you can only see just a little bit above, beyond 3 miles, at 6 foot off the water? All right. Thanks a lot for watching, and I hope this helps.